And for the ones that have been listening to Magnus' presentation before lunch, I guess that is most of you, this presentation is basically about two things that he said. And one thing he said was that it's important that the society needs, when it comes to Internet of Things, are targeted. This efficiency, sustainability, and safety. And that I definitely agree to. The other thing he said was that connecting things is not a problem, or the technology to connect things is not a problem. And that is a thing I don't agree with. So this is basically about these two things. Embedded systems, we've heard a little bit about that, so I probably skipped this one. I mean, embedded systems, basically the idea is putting a computer into a thing. When you talk about Internet of Things, then you basically talk about connecting the computer that sits in the thing. So I will go away from that, but one thing is that you can see basically, I mean, what happened until now is basically that you put computers into very defined things, defined objects. So what happens if your defined object is not defined anymore? If it's a very complex machinery, a very complex object such as a city. Many of embedded things are used to, for example, monitor the condition or a condition of an object such as a car and can tell you if something is wrong. And that's of course something that you also want in other scenarios, such as in the city. I mean, I never drove the city. I played SimCity when I was young. Maybe many of you did the same. So you can maybe some way imagine, well, this is pretty complex. I mean, you have to take care of a lot of things. And that comes basically into this efficiency kind of thinking. So what if, Bengt said that in the beginning, what if we could drive a city in a way, the same way we drive a machine or we drive an industry? I mean, you have a control room, or you have an automation, you have automated data collection about a condition. And this project, which is basically a little bit of a side project from us, working together with Sundsvall Kommun, this is basically about that. How do you collect information about a condition of a complex machine, such as a city, a very undefined machine or object? Of course, I talk about the Internet of Things, and I was very surprised that I haven't seen this graph, because normally when you listen to an Internet of Things presentation, you always see this graph. I mean, this is a typical Gartner hype curve. When it's Internet of Things, you typically talk about emerging technologies, so they have that for many different things. And if you don't see it, Internet of Things right now, 2015, is somewhere here on the top. The reason I want to show that is not to show you, well, Internet of Things is on the top, but basically what comes next. And usually when you talk about emerging technologies, the thing is when you are at this very high top, what comes next is you go down. And this is the second thing I want to talk about, and that connects to this technology kind of thing, that I think it will go down, and I think there are some reasons why it will first go down. Hopefully will go up in the end again, but there are some reasons. So if we look a little bit, and we have heard about that also from Bengt and from Magnus and from many others, I mean, the common drivers for Internet of Things. I mean, the common drivers are basically the same things that have been driving these. I mean, processors have been cheaper and faster. Communication becomes cheap to have everywhere. I mean, Wi-Fi or any other type of wireless communication. And then everyone talks about sensors become low power and small. And in some way, of course, that's true. If you look at these, for example, these have sensors, but they have a very specific type of sensors. And that's a bit of the problem, I think. But we come there. So I thought I will go through 3 very short examples what we've done with Sundsvall Kommun, which goes towards this condition monitoring of a city. And the first case is air pollution, which is something that can be a problem in a city, especially specifically for health of people that live in a city. And since more and more people live in cities, and people drive cars, and we have industries, this becomes some sort of a problem. And the problem is, well, right now you of course measure air pollution, but either you do it manually or you do it with extremely expensive and large measurement stations at a single or maybe 2 spots in a large city, which of course doesn't really give you a very good image. I mean, ideally we would like to have something like this. I mean, you want to know, you want to have a map over a city, and you want to know, I mean, where is pollution a problem? What can we do about that? If you think about, okay, if you have a condition, you also want to react to that condition. So what we did there was basically we looked at, can we somehow miniaturize and simplify air pollution monitoring, maybe with less performance, but at least to get an indicator of, can we get some kind of a map? So the thing that I wanted to show here basically is you need many sensors. You not only need one sensor, but you need many sensors to create this kind of map. If we look at the second example, it's about a very similar problem. It's about water pollution. If you look at daily water, I mean, that basically runs into a lake or into a river, you might get something in there that you don't want. I mean, you want to have rather clean water in there. But you might get things like, for example, oil in there. I mean, if you have a big garage or parking spot or industry close to a well, I mean, then you basically get water that can be washed by rain, for example, into your day water that basically then ends up in your lake and river. And of course, that's also something you don't want. I mean, that's something about sustainability, again, about health. And you want to have an efficient way to detect that. Interesting was when we started that collaboration, we heard how they do this now. They go around when they suspect that there might be oil in the water. They open a well, they smell. Is it oily? Oh, could be. Yeah, and then that's it. I mean, it's not very efficient, and it's definitely not very precise. So what we were looking at was, can we build a system basically that we can set into a well, and that can measure oil content in the water. And here you have basically a sensor that measures oil in water, in a liquid, and then you basically have your thing that connects the sensor to the internet. The third example is water consumption metering. I mean, okay, I could give one thing more. I mean, the same as with the air pollution problem here, it doesn't help you if you have one of those. You basically need many of those, because then you will be able to know, where does the oil come from, where does it go, is this actually a problem that we have oil here? It doesn't help you so much with one. If we look at water metering or water consumption metering, that's the third option. Every one of you knows that at home. You have these kind of nice water meters that count how much water you're consuming. Once a year, maybe you go down there in your basement or wherever you have your water meter, you take that number down on a sheet of paper, you send that paper to your water utility provider, and you hope that you get the right bill back, which seems not very 21st century anymore, especially if you compare it to how you measure electricity consumption. So what we did there basically was we just put a small device on top that basically takes that task, the same task that you do from you. It looks at the number, it writes down the number, and it sends in the number to your utility provider. That itself might sound like a gadget for one person, and for one person, okay, it makes not such a big efficiency difference. But if you look at the bigger picture again, if you have multiple of these systems, so if you imagine everyone in the city has one of those, you basically get a very nice database on current consumption, current water consumption. And that allows you, for example, to say things about leakages in the water network, in the utility. How good is your utility? How good is the condition of your utility network? And I would guess there's quite a lot of cost in maintaining a water utility network. So if we compare these three things, then we come to my last slide. Well, if we compare these three things, we see some common problems. And it comes back to this technology drivers that we seen in the beginning and the technologies that are actually needed. Of course, yes, we have communication, we have Wi-Fi, we have 3G or 4G or 5G or whatever you want to have. But if you want to have, for example, hundreds or thousands of devices in your city, you might need different types of wireless or communication technologies. I mean, if you have a water meter like this one, and you want to pay, let's say, $10, $15 for this, you don't want to have a 3G connection or a 4G connection with a monthly bill of maybe another $10. So you basically need some kind of more large-scale, efficient, and robust communication. Same as when you look at sensing. I mean, yeah, we talked about, of course, we have low-cost and low-power sensing, but the types of sensing that we need in these applications for example, condition monitoring, I mean, there are very different types of sensing, and they're not low-cost and low-power. I mean, here we talk about cameras. Cameras itself are maybe not so expensive, but they need quite a lot of energy. Here we talk about fluorescence metering. I mean, this device alone is like 20,000 crowns. And then you have a cheap one. I mean, it's not something that you scale up to a city scale and say, oh yeah, we have low cost and low power sensing. Here we talk about air quality meters. I mean, a measurement station for air quality sensing costs millions of crowns. So this kind of, oh yeah, we have low cost, low power sensing and what you actually need. So what drives and what you need is not always the same. And then, of course, we have talked about energy and that problem we have, of course, here as well. So basically, my point here is, I mean, there is research needed in these areas. And that's basically the research that we're also doing in other projects. You've heard about it in ACES and from smart grids. I mean, we need this research. And I think that this technology gap between this, what we need, and the technologies that we think we have, that will result in this drop that comes in the Gartner curve. Thank you very much.